Good morning, everybody. A special guest here with me today. I just wanted to go over the notes from Monday real quick. The properties of definite integrals. So you guys, most of you guys turned homework in for this already. I just wanted to go over everything just to kind of clear up any questions that we might have had. So the first, really all these properties pretty much make sense. Like number one, if you're finding the integral from A to A, of course, it's going to be equal to 0 because if you go try and find the area underneath a curve from one point going to exactly the same point, there's no area underneath the curve, so you're going to end up with 0. Number two is kind of just talking about if you're looking at an integral from, let's say, for example, from 0 to 10, and you know the integral from 0 to 5 is a certain value, and you know the integral from 5 to 10 is a certain value, you can really look at those separately and then just add them together. Number three is basically saying if we know the integral from A to B is equal to a certain value, if we switch the integral limits and we can now go from B to A, our answer is just going to become the opposite of what it was already. 4 is pretty much saying the same thing. 4 is pretty much saying the same thing. 5 is just saying that if we have a constant in front of our function, we can take that constant and pull it out front. 6, that property is talking about whether if we have two functions added together or subtracted, you can really break those apart and look at it as the integral of f of x plus or minus the integral of g of x. Number 7 is talking about an even function. So even function has special properties with around the y-axis symmetry. So if I know the integral from 0 to a is a certain value, if we reflect that across the y-axis, we know that we're going to have double of that area going from negative a to a. 8 is talking about an odd function. Odd function has origin symmetry. So if I go from negative a to a, which is the same value from one to the other, this area right here would be negative, this area right here would be positive. When we add them together, it equals 0. There's the next page of the notes. Really, there's one here that I thought might have been a little bit interesting, showing up in terms of how they get the answer, because then it showed up in the homework as well. Which was this one right here. So if we look at this one, it says the integral from 3 to 7 of 2 plus 3 of f of x. So the first thing they really did is they break that apart as the integral from 3 to 7 of 2 dx plus 3 times the integral from 3 to 7. So this right here, we know because they give that to you in the direction. So if I look at the other one, the integral from 3 to 7 of 2 dx, we don't have any information about that part of it showing up in our directions. So we basically just have to integrate like we normally would and then find the answer. So the antiderivative of 2 is 2x. Then I'm going to plug in my two values. I plug in 7 and then minus plug in 3, which is what they did. You do have a problem in your homework that showed up like that. Actually, I think there was a couple of them that showed up like that you're going to have to pay close attention to, because if you don't have any information about that part of your problem, then you're going to have to integrate there and then actually find out what the answer is. Okay, so let me move down here. All right. So down here on this last page, they're basically talking about asking you to find certain values. So they give you that f of x is pictured over here. So remember, if we are finding the antiderivative of a function that's given graphically, it's basically asking you for the area underneath the curve from one value to whatever the other value is. So in this first one, what is the value of the integral from 0 to 3 of f of x? We're really just finding the area of this shaded region from 0 to 3. This question is basically exactly the same. They just split it apart because we have a large area that's above the x-axis and we have another area that's below the x-axis. So they go from 0 to 3, and then they subtract out the value from 3 to 4, since that would be a negative. You could easily just go this area plus this area, because this area is going to end up being negative. This example right here, what is the value from negative 3 to 3? That's not so bad because we already found the area from 0 to 3. And it's symmetric about the y-axis, so all I have to do is just double my answer from up here. We want to talk about these two real quick. So this one right here, if f of 0, so f, capital F, being the antiderivative of the function that's given, what is the value of f of 3? So we know that if I take the integral from 0 to 3 of f of x, the antiderivative of f of x is capital F. So then we would have capital F of x, which would kind of look like this. Emma's having some fun today. And I'll be going from 0 to 3. Sorry, 0 to 3. So I'll be plugging in 3 and then minus plugging in 0, which is what they have. So this right here, we can find, because it's the area from 0 to 3, we know f of 0, that is equal to 5. So then we're basically just left with a statement. Here's my area is equal to f of 3 minus 5. And then we're just trying to isolate and get f of 3 by itself. So all they did is just add 5 and then just kind of simplify. This example over here, they pretty much did exactly the same thing. The antiderivative from negative 2 to 2 of f of x dx is going to equal f of 2 minus f of negative 2. Just plugging in our term limits to the antiderivative. So once again, this right here is our area from negative 2 to 2. So you can find the area of that however you want. You can find the area from 0 to 2 and then double it, which is what they did. You can find the area from negative 2 to 2 and add them all up. It doesn't really matter. But then basically what you need to do is get f of 2 by itself. So, well, that's really all of the notes. You guys have another kind of small worksheet that you guys have to do today. And that will be due on Wednesday by the end of the day. On Thursday, I'm going to post another lesson. And then you guys will have that to do by Friday. And then we have the following week off for spring break. So say bye, Emma. Say bye. I hope you guys are doing well. We'll see you.